Hi everyone, and welcome to our video on representing signed numbers in binary. Sorry, my cursor may get a little annoying. It looks kind of like a spotlight, and it's kind of just sporadic because my mouse isn't working too well, so sorry about that, guys. First, we're going to talk about what the three methods are for representing signed numbers. First, we have a signed magnitude system. Now, this isn't the hardest system in the world to understand. It's actually pretty easy. All you do is you say the first digit determines whether the number is positive or negative. We're going to look at an example for that in a minute, but just remember, if the first bit is 0, then it is positive, and if the first bit is negative, then it is, if it is 1, then it is negative. The pros of this is it's very user-friendly. Person just says, okay, 1 is negative, 0 is positive, I'm done. There we go. But the con is that the user loses out on that fourth bit. That first bit there is being consumed as a Boolean value of true false or 0 1, whether it's positive or negative, rather than being another number. So if you were to have 4 bits, you can only have 8 different numbers rather than 16, because it would be 2 to the third plus that 1 0 1 possibility of it being positive. Now let's look at an example there, and we'll see here. There we go. So here we have a 7 minus 3 example, which is the same as saying 7 plus negative 3. So we have the 0 there to say positive 7, and a 1 there to say negative 3. But as you can see, we top out here at 7. We can't have 15 or 11 or any of those numbers with 4 bits like we would in another system. We can only have 0 to 7. So enough of that. Let's add these together and see what happens. We go 1 plus 1. That's going to have a carryover of 1, but it'll spit out a 0. 1, 1, and 1 is 3, so I have a 1 there and a 1 up there. And a 1, 1 will be a 0 and a 1 there. And then you'll have a 1 and a 1, which would be a 0, and then you'll put a 1 way over here. But that is cut out because we're only using 4 bits right now. So what number do we get? We get a positive 2. Now, that's not really what we were looking for, but I guess this isn't really effective for addition and subtraction. The point is, this really is an easy way of counting or recognizing signed numbers, but it's really not effective at all for addition because it will always give you the wrong answer, or at least every time that I've actually done it. Now, to fix that, they gave us another system called the ones complement system. Now, this is found by inverting all of the bits in a given number. So if you were to have 0, 1, 1 as 3, the inversion would be 1, 0, 0. And that would be a negative 3. We're going to look at that in a minute, but just remember, in addition, if we were to carry over that one bit that usually gets cut off, we will apply that and we will add 1. So that's why it's the ones complement. We're going to see what happens there and look at pros and cons here. First, it will allow a user to add and subtract and will actually give us the right answer. We can also use the full potential of the bits. So if there are 4 bits, we could have 15 or 16 different possibilities instead of just 8, whereas in the other system we only had 8 possibilities. It is a little more confusing because you don't always know how the carryover is going to work, or you forget about it, whatever. It's not really a blanket statement because sometimes it does and sometimes it doesn't. Now let's see here, we have a ones complement example, 7 minus 3, positive 7 there, minus a negative 3. Notice how we inverted the bits. It would have been positive, it would have been 0, 1, 1, but it is 1, 0, 0 to be negative. Let's add those together. 1 plus 0 is 1, and the 1 plus 0 is also 1, and 1 plus 1 is 0 with a carryover of 1. Now what do we do with that carryover, that remainder? We bring it to the bottom and we add to the sum, or in this case the difference. Now we have 3 plus 1, which is 4. Now do we get the right answer? 7 minus 3. There we go, I'm counting my fingers here. And there we go, that's the right answer. So, obviously a lot more effective than the signed magnitude. Now let's look at our final system, the most efficient and most commonly used, the 2's complement system for representing signed numbers. It is found by inverting all the bits in the given number and then adding by 1. So you don't add 1 like right there, but you're going to add it the 1 at the end. So let's see what happens here. We have a 7 minus 3. We have 7 plus negative 3. And then the fourth bit, remember that it's going to get cut off. So let's do 1 plus 0, which is 1. 1 plus 0, which is 1. 1 plus 1, which is 0, with a carryover of 1. Now, whether this was a 0 or a 1 would be added to this sum. So in this case, it is the same, it's 4. But in other cases, if it were to be a 0, you would still add 1, and you would still get the right answer. It is definitely more efficient because it's a blanket statement. You always add 1. You don't have some, oh, so it's a 1 you carry over, and it's just, I guess, an easier way of doing things. The cons would be probably the same as the 1's complement, the fact that you have to kind of understand that rule and make sure you'll implement it every time and don't forget. So basically, it's a pretty easy concept. Thanks for listening, everybody. If you have any questions, please talk to your course instructor and do a couple of these problems yourself. And try and do more than 4 bits, because a lot of people just kind of get the basic concept and then they don't understand it all the way. And then, test time comes and you felt like you were adding 2 and 2, and then they give you like a square root problem and you're like, what? So that's definitely how I felt. So just make sure you know this, and it'll take a couple minutes, really. So good luck, everybody, and hope you enjoy the unit that's coming. Okay, see you around.